I'll do an intro just in case I put this on YouTube. Hi, I'm Tom and I talk about code. Welcome to another PlayStation 2 development live stream. This is going to be a chill stream. It's Friday night. My dinner plans fell through. I'm home a lot earlier than I expected, and so let's just try and fix some stuff up that's been going poorly the last few streams, okay? These texture issues are plaguing me. I've got a few VODs that I just haven't put on YouTube because they weren't very interesting, because I was just failing to solve the same problem over and over again. And I realized that part of that is because of this, okay? I made a commit to main and then forgot about it, so I'm hoping that when I do git reset hard origin main, git reset hard origin main. Okay. Now if I make run, let's go make clean, make run. Okay, that's not good. Apparently make run does not have build as a... Why doesn't it have that? Run has script as a prereq. Okay, it doesn't have the actual build as a prereq. Let's make dist. Make run. And it frickin' works, doesn't it? That'll get you, okay? Watch for regressions. Well, it's not even a regression, right? There was never a regression. The regression was a lie. I just was not up to date with master. Okay, that's good. That's good news. So, I guess maybe I do make a plan and put this on YouTube, hey? So now we can actually do stuff, right? Now we can actually solve this texture problem that we've had. So what was the problem? The problem is, and the reason this is so weird, and I talked about this last time, okay? I'm going to talk about it again. I'm going to pretend the last stream didn't exist, and we're going to go in hard. So YouTube people, I'm sorry, you're going to have to bear with me for a second while I start to draw this out. I don't have a mouse plugged in at the moment. I'm a trackball boy only, so my handwriting's going to be even worse than usual. Okay, so when you talk about transparency, right, you have an equation that looks like this. You have a source color multiplied by, let's call it AS, right? The alpha of the source color, AS. And you add this onto plus... let's call it D, a destination color, or like a background color, multiplied by 1 minus AS. I am being so careful to write this neatly with this trackball. It is very stressful, okay? Very stressful. So you have this kind of equation, right? This is how you blend colors with alpha. The destination is the background, the source is the thing in front of it. So if the source is very, very transparent, if AS is very, very low, then S goes towards 0 and D goes towards D. If the color is very, very opaque, if AS is close to 1, then the value of this bit is very close to S, and the value of this bit is very close to 0. The background has less of an impact on the foreground color. If A is 1, then this whole bit here is S, and this whole bit is 0, right? It disappears. The whole background disappears because it's opaque. And this is great until you get to the PlayStation 2, because the PlayStation 2 has alpha in the range of, for some reason, 0 to 2. Let's say on. Oh, I mean, trackballs are actually very nice for drawing circles once you get the hang of it. On P, I need to not get distracted. PS2. Okay, there we go. So, it's in a different range on the PlayStation 2, but the blending formula is the same. So if you plug the number 2 into this formula, it gets a bit weird because you double the source input, but then also have 1 times the destination. So you end up just adding colors on top of each other and getting new... I call it kind of like super opaque, right? Not only is the foreground color there, but the background color's there as well. Why? I don't know. And it's bad. So when you think about how these numbers are represented, though, if we have an alpha channel, so a conventional alpha channel, let's go over here, let's say PC, okay? A equals, let's call it X, 0. This is transparent. And A equals X, F, F. These pixels are opaque, okay? So these pixels, the ones that you can see through, these are the pixels that are fully transparent, and everything else in between gradually gets more and more opaque until you hit the value FF, okay? So, now let's think about the PS2, right? How do these values map into the PS2's range of 0 to 2? Well, 0 is still 0. This is a linear relationship. But where we want something to be fully opaque, we now want the value X. We either want X80 or X7F, I guess, but let's go with 80 for now. And then the PS2 also has this mysterious value of FF that does something, right? It does something, in our case, that will be undesirable 100% of the time. So let's put like a question mark here, right? This has no equivalent in PC programmable pipeline, conventional, like, or standard practice, I guess, for PC programmable pipelines. The PS2 is a fixed pipeline, right? We can't change this blending equation. We can't just invent our own blending equation that handles the range 0 to 2 better. We're stuck with this equation and this range of alpha. So we need to do something about the fact that when we load an image in TGA format, right? And I showed this last stream. Let's go XXD, and this is just a tool that dumps the binary data or something, right? So let's have a look through this. And you can see, okay, here's some stuff. Here's where the pixels start, right? This is a fully opaque black pixel, okay? No, red is 0, green is 0, blue is 0, alpha is FF. So if we draw this semi-transparent layered over another copy of itself, what happens when we blend these colors together? Well, because they're 0, nothing interesting. But what about some of these other pixels, right? What about some of these? There are other pixels in here somewhere. Okay, let's take this pixel for example. Blue, green, red. I got my red, green, and blue order backwards for a TGA. Okay, so this is red 47, fully opaque. Let's take red 47 fully opaque and red 94 fully opaque. It's not 47 and 94. It's the hex equivalent. So let's go 4, 7, over 9, 4. And let's plug it into this equation, right? So on PC, let's actually just take them as the numbers 47 and 94 because it's easier to do maths with them, right? Well, on PC, we don't really have to write it out. They're both fully opaque. The AS is fully opaque. So we multiply S by 1, right? Let's write it out. Otherwise, I'm going to be saying too much. Let's go S equals hex F, which is the equivalent of 1.0. Okay, so this becomes 47 times 1 plus 94. And again, these are actually hex numbers in the file. We're just going to convert them to decimal because it's easier. Times 0. This is just 47. If we do this on the PlayStation 2, we get something unexpected because on the PS2, hex FF, it represents the value 2.0, which is odd, right? Because now we get 47 times 2 plus 1 minus AS. Well, this is actually, so 1 minus 2, this is actually negative 1 times 94. And that's going to give us, it's going to give us something. Let's see if we can find our terminal window here. That's going to give us negative 94. It's going to give us 0. That's going to give us 0 just by chance because 94 is 2 times 47. So these were bad numbers to choose. If I choose literally any other number here, here as well, right? So I'm just going to like pretend that we picked a smarter number at the start. Let's say we're going over 50. Let's say the background color is like 50. So minus 50. Is hex 47 double hex 94? It isn't, is it? Anyway, sorry, that's neither here nor there. This then becomes 94 minus 50, which is 44, which is a very different number. I mean, not very different, slightly different. But you can imagine as this background color changes, then this result varies in a way that's unpredictable or not intuitive. So PS2 alpha is weird, in conclusion. And all these pixels that are FF, they're not going to be represented in the way that we want them to. TGA maps this on a range of 0 to 1. We need to crunch this down. We need to halve the range. So every FF needs to become an 8-0, and every 0-0 needs to stay as a 0-0, only in the alpha channel, and then everything that's like halfway in between needs to be halfway, you know, so if we had hex 80 here, it would become hex 40, right? We need to crunch it all down to half the range. We can do this. We can do this. It's not that hard. So let's do this properly, right? We half-assed it last time. Let's go into our TGA loader. And when we load our TGAs, okay, load TGA lure, where does it happen? It happens in here. So 16 bits per pixel, we don't have alpha. 24 bits per pixel, we don't have alpha. 32 bits per pixel, we do have alpha. So let's say if header dot, so if we're in 32 bit per pixel mode, you know, we have kind of special behavior for 24 and 32 because we have to swap the red and the blue elements of the TGA raw pixel data. But in 32 bits per pixel, we're going to have some extra special behavior. We're going to take, so, you know, the buffer here is just, you know, raw dump of pixel data from the TGA, right? So we're getting the pixel at I times j, right? So like I pixels across by j pixels down, multiplied by the bits per pixel to kind of, you know, get to the right offset. And we're going to add on, so in 32 bits per pixel, it's blue, green, red, alpha. We're going to add on 3, right? The 0th, so this is the red channel. This +1 gives us the green channel, +2 gives us the blue channel. That's why we do this swap here with +2 and not +2, right? +0, I guess. And +3 will give us the alpha channel. So let's say this equals, can we divide by equals into an array? Can we do this? I think we can do this, right? And it's just a byte. It's just a byte, so this should be fine. So let's try this. What happens if I make this? Is it angry with me? It's fine. That should be good. Okay, so we've crunched the alpha range down in half. So what if, do I have a texture that has transparency? That's not what I want to do. That's not the thing I want. What's a good example? I really need to get rid of that image. I don't think I've attributed it properly. Let's make a texture. Let's make a new texture. We did this the other day. We're going to do it better this time. It needs to be 64 by 64 because that's just a thing. We're going to go layer, transparency, add alpha channel, and then we're going to pull the opacity down to half. We're going to have this nice weird purple color. We're going to export it as a TGA. We're going to go, where are we? Let me just, I don't ever know what's in my home folder. I really need to keep it cleaner if I'm going to be streaming. Oh yeah, just some kind of like unique identifier for my phone. That's fine, right? That can't be any harm in that getting leaked. Let's go in PlayStation 2. I am just going to PS2 Homebrew Examples, Asset, and let's make, let's call it half.tga, okay? We're not going to compress it, and the origin is going to be the top left, and we're going to pull this in. Okay, so we're going to go into our example. Instead of grabbing in test.tga, we're going to grab in, what did I call this again? I already forgot. Half.tga. We'll remake the assets, we'll run, and hopefully we'll see a nice semi-transparent thing here. We see it here, we don't see it here. I don't know what this is. Am I setting a weird color? I am setting a weird color here. So again, I want all my colors to be fairly well behaved. Okay, here we go. So this is rather transparent. Let's crank the opacity back up to 80, hex 80, you know, the halfway point of the range. That's not what I wanted to do. Here we go. Okay, so we've got these nice semi-transparent things. Now, let's, I could either do this with like a for loop, or I could just dumb copy and paste it. Let's just dumb copy and paste it for now. So let's replace 20 with 30 on the line. Let's replace 20 with 40 on the line. Let's do one more. Let's replace 40 with 50 on the line. And then we'll run. Cool. And that looks like opacity is being correctly applied, which is good. That's good news. That's very good news. That's awesome news. I don't know how it took this long to happen. Let's do this. Let's go test 64 by 64. So the problem was within ourselves, okay? We were looking for problems in the PlayStation 2, and the problem was inside us all along. Awesome. Awesome. Let's call this... Let's call this test text 2, I guess. Let's just use horrible names because this is testing code and it doesn't matter. Test text 2. Okay, now I just need to modify a few things, get this example working. Ooh. VRAM 42 Lua text. Attempt to index a nil value. Local text. That's not good. Local text, nil value. So if I go to vram.lua, where did that come? Texture, text. Text was nil. Text was nil. Because I'm passing it something that is not... Lua is so lenient with this stuff, okay? This isn't an error. It just defaults to nil and... Or does it? Hold on. Did I make a typo up here as well? No? No. That is insane, right? Like a typo is just fine and it'll happily go and crash and blow up. Let's come in here and let's call this test text 2. And let's have a look at what we get. Okay, that didn't quite work. That didn't quite work. I was very confident. I was very sure of myself. Here's text.tga. This looks good. We read the thing. That looks okay. Calling upload texture with blah, 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 blah. This all looks okay. Why isn't this happy? What have I done wrong? What have I done wrong? Upload textures is all good. What happens if I don't do the sprites? What happens if I get rid of them? Do we get a better outcome? No. Oh dear. Okay. Hold on. Hold on. What if I swap these textures around? What if I make you test text 2 and you test text? What happens then? What do I get? Give me something. Okay, we're still not loading the test texture, but that's okay. That means that it's not just a... It means it's not just some weird oversight, right? This means there's something else going on. This isn't actually that important right now, but I would like to fix it. I would like to fix it. What if we just get rid of this other texture, right? What happens then? But then make this... What happens here? What happens here? We get nothing. Weird. Okay, so what's the diff here? What has changed? Host test.tga. Host test.tga. We're doing the same, we're loading the same thing. We're trying to load the same texture that we were loading before. Test text 2. It really looks fine. It really, this weirdly worked before. Alright, let's just ban that guy from chat real quick. It's not, where are we going? Get rid of them. They're gone. They're out of here. Okay. Okay. I mean, this is good though, right? This is good. Let's check out a branch rather than committing to master. This is what bit us in the ass last time. Let's go TGA alpha crunch. Let's commit crunch alpha let's do this. I think this is good. I think this is good. So let's try. What happens if I make run from here, right? Well, apart from that. Apart from that. I'm actually going to remake some makefile changes from the last stream that I completely forgot about and nuked when I reset my branch there. But let's get rid of this dynamic name thing. Where is it? Let's just call it p2g.elf. Let's just call it p2g.elf, lowercase, right? Either all lowercase or all uppercase. Let's go all lowercase. Dist bin name. Yeah, sick. That's way better. That is way better. How's everyone doing tonight? How are we feeling about PlayStation 2 dev? It's weird, right? It's a weird, slow, painful process. Okay. And it suddenly does not like this texture. Well, let's open it up and have a look at what's going on here. Let's see if we can't suss this out. Let's see if we can't suss this out. PlayStation 2 homebrew engine assets. Where are we? Test.tga. Looks freaking beautiful. Does it have an alpha channel? Has an alpha channel, 32 bits per pixel. We know this. We know this because we can inspect it. Let's dist test.tga, right? Looks beautiful. Looks freaking beautiful. So something about this change stops this rendering. Something about this change stops this rendering. Why? Why? If I go back to the texture example, right? Oh, well, we're setting the alpha very low here for some reason. That could actually have something to do with it, or not. Okay, why suddenly does it not like this texture? Why does it not like this texture? I would expect every alpha value here to be hex 80, right? Every single one. Or hex 7f, because C should round down. Let me re-export. Let me just re-export and see what happens, okay? Replace top left, no RLE, boom. Weird. That's so weird, right? I feel like this change should not induce this strange impact. Let's go back to it. Let's go back to it, okay? Let's go back to this weird hard-coded case. Let me just like comment it out. And it's gonna work this time, surely. Yeah, okay. Okay, why? Why does this happen? Why does this happen? We can crack this, okay? We can crack this. So, this change stops our texture drawing. Now, we're calculating the offset of this pixel correctly in the buffer. That's good, right? There are 4 channels of color. The fourth is alpha, so this pixel index plus 3. Now BPP is the number of bytes per pixel. We calculate that up here by dividing the bits per pixel by 8. BPP and BPS are 2 very confusing names. I should make this clearer, but this is okay, right? BPP is 4. So we have this stride of 4. We walk through the thing. This works for semi-transparent textures. It does not work for fully opaque textures. Well, I guess the other thing we can do, right? We can take another texture. We can see if it works with one. So let's go half, right? We can see that we draw something. Oh. Now we just have no transparency, right? Now we just don't have any transparency. Oh, because we're setting this to FF 8.0. No more super transparency, please. Okay. So you can see these are kind of like a little bit see-through. It's hard to tell because there's nothing behind them, but that's okay. That's okay. Okay, that's good. That's good, right? So what's the difference? So, oh, hold on. I need to remake this as well. Okay, this is good. This is good. We have the correct alpha now. Let me just like put a squiggle or something on this so that we've got the right kind of look, so that we know which way this faces, right? Let's put an up arrow on it. Okay, so we'll export over half. Beautiful. Make assets. I really need to. Oh, good lord! I really need to make this. Yeah. So you can see we've got this up arrow. We've got orientation correct. We've known this for a while. Okay. Okay. So what are we trying to show? What are we trying to show? We're trying to show that a fully opaque texture does not like this change. So let's make it fully opaque. We'll override half. We'll make assets. We'll make run. And they disappear. Bam. And the dirt is gone. Let me make it a little bit. Let's go 99% opaque. How opaque does it have to be before it vanishes in this bizarre system? Okay. There we have it. So I'm sitting down and I'm asking myself, right? What is the difference between these two textures? The difference is that one was semi-transparent and the other was not. So for some reason, this TGA loader code, this TGA loader code, this TGA loader code blows up when the texture is fully opaque for some reason, even though that makes literally no sense. What else? Where else? So this is the only place we check for 32-bitness. Can I just like dump the buffer somewhere? That would be cool, right? Let's maybe, where's my print buffer function? Somewhere in utils, right? Everyone's favorite general purpose file. Okay, so let's go print byte buffer. This really should be called something else, but we're gonna not interfere with the status quo. If def log trace, then if log output. This is very noisy logging, so we are just gonna actually. Maybe I'll just hijack this, right? Maybe I'll just hijack this, and not print the last few pixels. I'll just use the existing print buffer. That's good. It'll get formatted nicer, right? If we're just printing a generic stream of bytes, we don't really know where we should put the new line. Whereas if it's quad words, then there's an obvious place. So let's go print buffer. When we get to the end here, we'll f close. We'll print buffer, and the length is gonna be. The length is gonna be size. The length is gonna be size. Where are we? Size divided by 16, flawed, because we're just not gonna care. There may be a little bit that doesn't get printed out. We will wear the consequences. We'll bring in utils.h. and that looks okay. Let's run it. Nothing's going to happen because we don't have trace logging on. Let's go back to our texture example. Let's run our example again. Let's have a look at some very noisy logging. This is our texture in all of its glory. Let us go back and do that again because I exited out of that a little bit too soon. We've got a lot to log. Okay, so this is our texture. No, this is our texture. What's this? Oh yeah, this is uploading our texture. Okay, so we get to see both, right? Find you a man who can do both. What is this? What is this? FE50B4 1B44. FE501B44. What color are you? What color? I think I just accident. Oh no, we're good. We're good. What color are you? 441B50. 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 Why is the alpha channel FE? Oh, wait, I did this before. I did this last stream. Hold on, we've got a problem. We've got a problem. Got a problem dividing by 2. It's because our car is signed, surely, right? I think if I go into this, and I maybe go cast it into an unsigned car pointer before I do anything with it. So maybe if I go like where are we? Unsigned car buffer. Does this work? I think this works. I bet this works, right? So what do the numbers say now? The numbers don't lie. We now have the correct alpha value, right? It was FE before, now it's 70. Dividing numbers, C, int promotion, I don't know, there's a lot of concepts going on here, right? When you divide a car by an int, I think the car gets promoted to an int, maybe, but then when you promote a signed car that has the value of -1 to an int, it becomes the int value of -1, which is FFFFFF. It's complicated, so it's just going to become 0, right? Because if you divide -1 by 2 in C, you just get 0, and then you cast that back, and signed int nonsense, right? This works. In fact, what's probably better than this, you know, like that looks disgusting. If you don't look at that and think that was a dirty hack, there's probably something wrong with you. Let's make this unsigned. Let's make this unsigned. And let's go back to where we define the buffer, and let's make the whole freaking buffer unsigned, okay? Where are we? Where do we pass it in as an argument? Unsigned. And it's going to yell at me because where I call the function blah, 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 doesn't really matter. Let us go and make this fully opaque again. Okay, we're going to make it fully opaque. We're going to export to half. We're gonna make assets, and then we're gonna run, and it's gonna work. Oh yeah, boy. Look at that. Don't you love it? Okay, so we're gonna get rid of this print buffer because it's too noisy. It's too noisy for life. It's no good. We're gonna go to our texture example. We're gonna pull in. We're gonna draw half. Test text. No, hold on. So yeah, we're gonna do this thing. We're gonna go test, and then we're gonna go. We're going to have a texture called transparent, which is going to be our half example. Let's just call it test text 2, and let's call this test text 1. Let's just go simple. Let's not overcomplicate things with names. Test text 2. This is also 64 by 64. It's going to make it very obvious when things aren't spelled correctly because they should be the same length. Beautiful, beautiful. Test text 1, test text 2, beautiful. Okay, we're cruising along. We're cruising along here. So now we're gonna say, draw this test text 2. How do you do a Lua for loop? Every single time I write a for loop in Lua, I have to look it up. Hold on, wait, no. I think I've got it. is it I equals 0 and then the number and then the thing, right? So if we go like 5 plus 1 do, is that it? I think that's it. We'll still Google it. For names in max value, and the increment is optional, right? Yeah, it's like this. So it's what I said. We do this, right? So we'll draw it, but we'll do this little offset thing we did before, but we'll just like codify it now. Plus I times 10. And we made a syntax error, but that's okay. Intended to index a nil value. Lure PS2 lure prog 69. Good line number. What has gone wrong? What has gone wrong? Has there been another error up here? No. No, there has not. God, we still need to do a lot for our error reporting. This is a little bit crap. PS2prog.c. So what is this? We just get an error when we call on frame. It's because that is just test text and not test text 2. Okay, now it's going to work. Now it's going to be happy. Perfect. But now we just need to go back to this test texture and we need to make it, you know, semi transparent. Now when we export it, now when we run, it's going to be beautiful. That didn't work because we need to do make assets. And now when we run, it's going to be beautiful. Look at that. That's what we want to see. Okay, so now we can go in. We're just gonna make this a little bit less red because that's a bit much. Let's just make it a nice neutral color. Okay, let's actually just not set the color. Beautiful. Okay, so fix TGA manipulation with signed, unsigned char. 1 character over 80 character commit message there, but that's okay. Git add makefile. I'm doing this one file at a time, okay? Because I want a nice clean commit history that I'm gonna crunch down on a squash and merge. It's very important to me. I'll know it's there. This is gonna be makefile doesn't use stupid. Let's keep this a bit more profesh. Version based elf name. Update texture example with opacity. Perfect. Okay, we've done it. We have done it. We fixed it. So let's call this TGA alpha crunch. Looks fantastic. This I'm very happy about. This looks great. This looks great. Yep, sold. Merge it. Ship it. Ship it. Squash and merge. Done. Okay, so and now we're going to pull this in to our game and it's just going to work. Isn't this crazy? Let's go minis, pew. We're going to kill whatever was in the engine. It's gone. It's dead. Maybe I should have tested that this worked before I merged it, but you know what? Screw it. Engine hash. We've done. I'm gonna wreck my glasses bumping this microphone, I swear. Okay, so let's go. Oh yeah, we've got a we've got to make Lua now. It's very exciting. We roll our own lure. It makes the first compile take like 10 times longer, but the rest of it's still pretty short, so that's okay. And let's do it. Sure, that was the example. Okay, now let's do it for real. Look at this. Look at this. Are you seeing this? Things eclipsing other things. Isn't that what you want to see? Doesn't this look like normal transparency? Isn't this what I've been striving for I don't even know how long at this point? It's actually insane. We have alpha for planets hard-coded, so let's just drag it down a little. Let's go to 60. Let's go to 60, right? What do we see here? We should see this planet turn semi-transparent. We should just be able to catch a glimpse of the player behind it. And maybe, I think if you look very carefully, but for the benefit of the stream, because that's not going to show up with my stream compression, let's make it very transparent, okay? So there's a planet there. Huh. But, of course, none of this matters when you override it here. So when I said I could see something through that, complete placebo. Complete 100% placebo. There we go. Look at this. This is transparency. This is what transparency should be. This is how transparency should have been a month ago. Okay, so let's go back to game.lua. Let's get rid of all this testing shit. What are we doing? Let's add a game manager back in. Let's get rid of this rock. Let's get rid of this planet. Okay. Let's go back to draw. Let's draw the stars. Let's draw the background. Let's do this bad boy. Let's have a look. Okay, I made a syntax error. We've got a black screen of death. Or not. We've got a bad buffer. We've got something. Something's gone wrong. Something has gone wrong. Oh, what have I done? Hold on. Okay, no one panic. Nobody panic. The important thing is that no one panics. We have a hang. Okay, so we're gonna have to dissect, unfortunately. Are we? Okay, hold on. I've got another theory. Let us... For one thing, let's just not draw stars, because that's a lot of noise in our draw buffer. Okay, that works. Let's go back to our planets as well. And just make them, like, a normal opacity. Make run. Look at this. Beautiful. There is a chance that that was just a one-off fluke. That drawing the stars is actually not a problem. And no, it is. Okay. BG stars. I can't actually remember quite how I'm generating this. So stars.new. Star. So this is one superstar entity, right? Let's lower the number of stars a little. I think that was the parameter to like control how many stars got drawn. Yeah, look at this. There we go. Okay, now we're getting somewhere. Let's turn off the really intense logging that we're doing. Where's Oh yeah, trace level, that would explain it. Let's go to debug level, that's okay. We understand debug level. We're not afraid of a debug message. Look at this. Oh, it feels so good. Look at this. I don't know why that many stars was too many. I don't know why that broke my render packet, but oh, this is fantastic. Okay, we've got a bit of slowdown, right? It happens. We're doing very inefficient collision checking. Lua is not good for collision checking, right? If long-term it's good for a prototype, but long-term for a game, we do not want Lua collision checking, right? That's not good. It's not good. And there we go. I mean, we're very close to a fully playable game here, right? What renderer am I on? Am I on the slow renderer or am I on the fast renderer? I'm on the slow renderer. Okay, let's Let's go. Let's go with the fast renderer. This is going to take off. Okay, hold on to your hats. We're cooking. This shouldn't even slow down at all now, I don't think, right? We've got a new game manager logic. It's not going to let, too many rocks spawn. This is cool. We need to improve our planet generation because they're a little bit at the moment. I want to have like little semi-transparent clouds and stuff that come through, and I've got thoughts for other things that I want to happen, but we'll get there. We'll get there. It's all an incremental process, right? Now these stars in theory blink. Oh, this is so good. This feels satisfying. Okay. Here I was at the start of the stream saying this was going to be just like garbage and I wasn't going to put it on YouTube, and we've done something. We've fixed a problem that's been plaguing my nightmares for like a month. And this feels so good. It feels so smooth to play. It's really hard to explain. I want to get this onto my real PS2 again later tonight. I hopefully am going to have a capture set up soonish. I've still got that fat PS2 I talked about a while ago that's broken that I need to fix up. I've got a friend who has a PS2, and I'm just trying to like, I want to try and, she's got a broken PS2. I want to try and fix her PS2, and then if I can't fix it, I'll just like buy it off of her and try and cannibalize parts off of it to fix my PS2. I don't want to just go out and buy a whole new PS2 that may or may not have the parts that I need. I don't know. Anyway, this is awesome. This is awesome. This works. This works. Holy crap. We're back into deving the actual game. Okay, so let's try and add more stars. Oh, hold on. Do you know what the problem was? The problem is that we're using the slow renderer. The slow renderer can't do with that many stars. The fast renderer can do with that many stars. Oh boy, can it do with that many stars. There we go. That makes sense. And there's still not going to be any slowdown because these stars are cheap to draw, I think. I mean, there's no lure churn in trying to draw them, right? So that's a bug in our slow renderer that may or may not be important to fix as time goes on. I think the slow renderer in general is going to be less and less important as time goes on. I'm finding it's actually just as easy to prototype in the fast renderer, unless I were to like seriously overhaul the way the slow renderer works to make it more descriptive. But I don't know if that's a good idea. Anyway, I've got a lot of thoughts. And this is looking like a real game now. I love it. Okay, so there is something else that we're missing. I think let's try and tick something else off tonight that's been bugging me for a little bit. We'll get this looking nicer, and then we'll have a clear direction to go from there to polish this off and make it something we can release. I don't think I'm going to add much more to it. I think I'm going to keep it a very small scope thing, but just kind of a, hey, here's a complete thing. You can download it, play it on the PS2, go for a high score, whatever, a complete piece of homebrew. Okay, so let's check out the diff for this. Okay, well, we can actually revert this. Let's go. We can actually just use the no host path, right? We don't need to specify the host. It's smart enough to pick this up. Cool, so in the planet we have the correct alpha values now, which is good. Well, let's get status. So let's add the makefile. And let's add the planet script as well. Cool. I love it. I love it. And we're just committing this straight to main. We're going to push it because I like to live dangerously. Cool. All right. So the other thing that has not been working, if we go into the game, actually let's go into the game manager. What have I called it? Game manager. Draw. Print lines. Why isn't print lines working? So in game, I think we set up a font, right? We should set up a font. T. Where's T? I don't think we ever set up a font. Main. T. T font, load texture, host big font. Okay, let's go. Fair. Engine dist big font. I wonder if I fixed this up. I had issues with my font spacing, and I fixed it, but I don't know if this is the fixed version. I might have lost the fixed version in my aggressive git resets. So why isn't this text drawing? Why isn't this text drawing? Let's go back to 8080 8080. Character get index, text drawstring text. Ah, yes. That's right. That's right. We got rid of the globals, right? Did we? Yeah. Yes. We fixed this. We made this better. So let's go to maybe. So we need to update this, right? So if you look, you know, text drawstring, text print lines, it actually takes in some parameters, right? Some parameters that we're setting that we're not using. Resident is false. Okay. So we need to deal with this. We need to deal with this. Let's go into assets.lua. And let's make a font in here. It's just going to be some like table. It'll start at 0. We'll pass in a font texture and some parameters, I guess. The character width, the character height. What else does this take in? That's it. Texture, character width, character height. Okay, so we're going to go local. Well, we're going to go a.font equals t.new. It's going to take in. No, hold on. We need to load the font. So we're going to go local font text equals d2d load texture. Here we go. Here we go. Font. So load the font texture, and then we need to upload the texture. So this needs to also be a local in the table font text. Sweet, sweet. We can assign it here. We can use it here. So we can say, hey, we can pass it as an argument with a character width and a character height. It doesn't get used until we actually try and draw something. So we can do this. And then when we also do this, we say a.font.resident equals true. So now we need to call load font before we call VRAM. This is a bit of a weird dependency, but we'll survive this. So we'll, instead of this, we'll say a.load font. The font is called bigfont.tga, and the characters are, I don't know, 12 by 8, I think. We'll see. But this should draw something now. This should draw something now. Or it'll crash. Or it'll crash. Failed to load TGA header. Because there's no such file. Failed to read file. Okay, okay. Here we go, here we go. Bigfont.tga. Bigfont.tga. Failed to load file. PewDisk12. Okay, so hold on. So something weird is happening here. Oh, because this needs to be a method. That makes sense. That does actually check out if I read the error better. Now it's a more sensible error. It's telling us that in assets.lua we don't have the global value t, and that is because in the assets.lua we have not required it. So local t is require text. I think it's just require text. Attempt to index a local value vr. Now this is more interesting. What have we done? Load text vr. If we go to main, load text. Yes, we accidentally deleted something important. We got rid of an important line. This was actually doing something that we apparently needed. Okay. We need to change this back to a method. Now when we run, everything's going to work. First time every time. First time every time. Where is it? Where'd it go? Okay, so if we go back to game.lua, where do we spawn the game manager after the player? Okay, so this should get drawn just like any normal entity. Should just get drawn. Except we don't want to call this on T anymore, right? We want to call. We have A here, don't we? We don't. A is require. A is for assets. Assets.lua. We want to call a.font print lines 10 10 score. This is going to print something. It may not be right, but it's going to print. I take everything back. This is not going to print something. Why does this not work? It probably doesn't work because this needs to be a method invocation, right? How about this? I feel like we're getting close. There we go. There we go. Okay, we've got some garbage up here. We got some trash up here. This is not quite right. This is not quite right. So, self.sprites, because we're not actually doing the thing. We're not actually doing the thing. v.texture self.font text. Maybe I should actually have this in here. I don't know. a.font. Oh no, wait, we did this. No, we did this. Load text to VRAM. But we need to put it into actual VRAM. Texture self. We need to actually load it. We need to allocate it into VRAM. Self.font text. Yes. Okay. There we go. There we go. That was what was missing. That was the magical missing ingredient. Now it's going to print something. And it's garbage, but that's good. That just means we've got the wrong dimensions on the font. So let's load up the font. Let's try not to show anything sus. There we go. Perfect. Okay. First off, why is this image bigger? What? What? What's... Oh, this layer's bigger. That's okay. Okay, so, I think this is not the fixed version. Let's view a grid. Show a grid. Maybe it is. But what is the grid? What is it? What is it? Where are we? Configure grid. 8 by 16. That's a little bit different than what I said it was. Main.lua. 16. Okay, let's see. Let's see. Also not quite there. Also not quite there. Let's check in text now for the culprit. Let's also just quickly like spin over here. Okay, we don't have globally defined text. That's okay. So car-s, car-wit. But how does it know when to wrap, right? This is what I want to know. This is what I want to know. X plus soft car-s and car-height. How does it know how many? It just assumes. It just assumes 32 characters per line. Okay. Let's formalize this as part of our thing. Let's go cars per line is 32. It'll be hard-coded for now, but it is a variable that we can, in theory, change. Self.cars per line. I love it. Self.cars per line. Now, does this hold out? 1, 2, buckle my shoe. Yeah, this is 32, right? This is, because it's 8 across 8 times 32. That's 2 to the 3 times 2 to the something. Yes. Right? 32. 256. 2 to the 8. 2 to the 5 times 2 to the 3. Yeah. 2 to the 8 divided by 2 to the 3 is 2 to the 5, which is 32, which is how many things across this is. Okay, so something else has gone dumb. Something else has gone dumb. Texture.width, texture.height. Now let me open the non-XCF version of this and see if it's slightly different. Is that slightly different? That is identical. Okay, so show grid. This grid, however, does not get stored as part of the image. That's good, that's good. Image configure grid 8 unlock by 16 pixels. Okay, why doesn't this work? Why doesn't this work? Self.drawString, that is fine. That is fine. Car width, car height. We're doing this right. No, we're not. We're sending these in the opposite order. 8 by 16, not 16 by 8. That's a very important distinction. That is a very important distinction. Okay, now you're going to see this S looks like it has a descender. It's not meant to, right? And this is because our font has been assembled very poorly. This is not how this font should be. So let's just like get a few things straight here. Okay, let's straighten this lad up. So this should be, we did not actually highlight anything there. Font. Okay, this should be. Well, let's start with this, because this is a more interesting and diverse row. Okay. So let's just align this to something that makes sense, right? Let's go font, and we're gonna squiz you down here, here, here. We're gonna put you in the bottom left, okay? Sorry, spleen font. It's better this way. So, how many pixels from the bottom is this? Let's get the old pencil out. 1, 2, 3. Okay, so the capital A should be the same number of letters from the bottom. This is the problem at the moment. They're not consistent. So how many characters down do we need to go, right? That's not the right brush. 1, 2, 3, 4. Okay, so we need to put everything down 1 character, which does in fact check out. So the lowercase was 1 pixel too high in conclusion. And I guess we could make a more vertically squashed version of this, but I don't think I really want to. And I think this is also 1 too high, right? 1, 2, 3, yeah. Cool. So we're just gonna like grab this row of numbers. We could have fixed this a different way as well. It didn't have to be quite in this. We could have just moved the lowercase 1, but this is fine. This is fine. Okay, there we go. So now when we save this, and then when we export this to bigfont.tga, we're gonna replace it. We're gonna no RLE compression top left. We're gonna add our symbols back in. Just a couple of shapes. I was gonna use these for things. I never have, but let's re-export. You know, the X, square, circle, triangle buttons are cute and useful. Let's that still isn't quite right. That still doesn't look quite right, does it? So where does S go? Where does S go? S 1, 2. That is not 1, 2, 3. C. Where does C go? 1, 2, 3. Okay, so I think we're in the wrong directory. Hold on. What? Where did I save this to? This is in the main engine. Okay, so let me just like grab the better font. So let's go back a few directories. Not that many directories. Assets bigfont.tga, and we're gonna put that in assets bigfont.tga. This should override it. This should override it? I don't know if it will. Yeah, it does. Cool. My font takes precedent over your font. Well, over my font, but you know, the me who like writes the core engine. He's constantly at odds with the me who writes like the gameplay logic. Awesome. So we've got a score. Well, we have text, right? We can do all kinds of other crap. Let's just like dump a bunch of text on the screen for the fun of it. Get me 5 paragraphs of lorem ipsum. I'm just going to grab this bit. Entity game manager.lua. Okay, so let's print some more lines. A.font colon print lines. Let's put this at 1040, I guess. And let's just put some line breaks in here where it makes sense. Let's just get some line breaks in this bad boy. Cool. Good lord. I really need to get better at navigating lines like this in Vim. I guess just Wing through it is okay, right? No one's gonna judge me too much for that. I don't know, this is a really dumb way to test this out. I just want to see what it looks like. I just want to see some text in this wonderful pixel font. Okay, let's do this. If this crashes or something, I'll be very upset. Very upset. Okay, well, let me see if that works. Oh no, hold on. I just missed a comma. That's it. That's all there is. That's all it was. Whoa. Hello? Something. I hit caps lock. Hold on. Don't you hate when you hit caps lock in Vim and everything just like explodes for no reason? Okay, here we go. Gonna put this comma back in. It's gonna work. It's gonna work. It's gonna be beautiful. It will be a sight to behold. Oh man, this is amazing. This is actually slowing me down. This is a lot of calculation to draw this much text, which sucks. Text should not slow us down. Let me just make sure. Yep, we're definitely not in a slow renderer. Okay, so text is slow. We have learned a valuable lesson. I guess this is a lot of drawing too, like with the stars and stuff in the background. We're probably thrashing the limits of our renderer. Okay, so in conclusion, text is fun. Now, we need to format the score. So let's go function. Let's just first check Lua string format width specifier, right? Lua must have some. It does have string.format. Okay. String.format and Lua allows. Okay. Okay. So we can actually, well, this is less fun, but so we should be able to go concatenate onto this strings.format, string singular.format. I've been doing too much. Go string format. The format is going to be 04s, I think, right? 04s, and we're going to format self.score, and this should say score 000 or 1000, right? Let's actually go back and make our starting score 0. Now we should say 000. There should always be 4 digits in our score. Cool. And then every rock we break, we're going to get 100 points, but there's always going to be that leading 0. So let's actually up the number of zeros. Let's make it 6 zeros, I guess. Nice. This looks a little bit more substantial. Nice. So now we just need like player collision so that we can die, and we'll have a game. That'll be it. That'll be perfect. It'll be workable, right? And then, you know, we could either, I might try and build like a little platformer one day, just see if I can, you know, kind of do a little Mega Man clone or something in one stream. See how much of it I can do in one stream. Because I think I can crap out a full game using this code now, you know, pretty much in a single stream, right? I know what I'm doing. It's workable. I can do transparency. All these things that pained me a lot the first time I did them for this should now go smoothly the second time. I still wouldn't be comfortable doing like a game jam, but like I'm making progress. And then once I'm happy with the 2D, we'll rework it so that it does 3D, and it'll be amazing. It'll be incredible. No one will have ever done anything quite like it before. It will be uncharted territory.